In this lesson, I will show you how to find the domain of a two-variable function. The first question is, find the domain of f at xy equal to question sine x plus y minus e to the power of square root x plus y power y square root plus 7xy over x to the power of 3 minus 8y. Think of f at xy as a layer. You can even call it z. So z is equal to the following, but it is in function notation, so we'll just keep it like this. To find the domain of this complex equation, we go term by term, starting with sine x plus y. We know that anything that you put into sine will give you an output. So any real number that is x or y will give you an output for sine. Therefore, there are no restrictions here. Let's write down an arc. Okay, so let's move on to the next term. We have minus e to the power of the square root of x plus y squared. Now we know it with square roots you can have negative numbers representing the radic. In this part, so x plus y squared needs to be greater or equal than 0. Equal to 0. So finally, in our last term, we have 7xy over x to the power of 3 minus 8y. We know that with fraction, the division of denominator, in other words x to the power of 3 minus 8y, cannot equal to 0. So for this, the only restriction will be x to the power of 3 minus 8y cannot equal to 0. Now I want to write, now we write the what? Now we need to write down the domain and get and set the notation, which looks like this. The domain includes the set of all x and y, and we write that as xy such that line right here and x and y are members of only real numbers, and then our restriction x plus y to the power of 2 must be greater or equal to 0, and x to the power of 3 minus 8y cannot equal to 0. Okay, so next let's move to the next question. which is find the domain of f at xy equal to equation square root y minus x times ln 2x plus y plus e to the power of x minus 5y plus 10 is xy. So let's start with the first thing. We have the square root of y minus x times ln 2x plus y. Now we have two issues here, y minus x. This radical must be greater or equal to 0 for the same reason as discussed in equation number 1. So y minus x must be greater or equal to 0 over here. We have ln 2x plus y. Two x plus y must be greater than 0. Can't even be 0, so we have to write 2x plus y must be greater than 0. E to the power of x minus 5y, where there are no restriction there. You can place any number and your real number into x and y and you will get an output. And the same thing for the last term, which is 10xy. So if we write the domain and set for the notation, I write down D includes the set of all xy such that x and y include only real numbers, x and y include only real numbers, and this time what I will do is solve for y in both of their cases, just to show you that you can have y must be greater or equal to x, y, and that where that I brought the x over and I end up with the following. If I bring the two x over here, I end up with y greater than negative 2x.